Write the structures of the products of the following reactions.
Structures of
Write the structures of the products of the following reactions. Now you have got reaction 1, benzene. Benzene reacts with C2H5, COCl to give in presence of anhydrous aluminum chloride and carbon disulfide. This is one of the very important reactions to require the aromatic heat. So here C2H5 and Cl. So this Cl and H can combine so that the HCl is removed. And what is the remaining one? CO, C2H5
plus HCl.
plus H. And this is propanone. Why? Because there are three carbon atoms, C2 and the C, propanone, where phenyl group is joined. So phenyl propanone. And where it is joined? It is joined in the first position. So one phenyl propanone. Okay.
But then you cannot.
Otherwise, this can be called the propiophenone. This can be called a phenone. And this can be called the propio. So propiophenone, just like the acetophenone. What is acetophenone? Acetophenone is C6H5, C0, CH3. This is called acetophenone. So what could be the starting compound to get this acetophenone using this kind of reaction? Instead of ethyl, we can put CH3. That's all. Then, second one, C6H5CH2 twice. CD, cadmium. That reacts with the 2 moles of CH3, COCl, gives water.
Cl. So let's say you come from an academy.
Now, so we have here C6H5CH2 means benzyl group. This is called benzyl group. C6H5 simply is called phenyl. So there is a difference between phenyl group and benzyl group. Okay. Now you have got diphenyl. What is that? Cadmium. Not diphenyl, dibenzyl cadmium. So dibenzyl cadmium that reacts with the CH3COCl. What is the product? Now let me illustrate this. C6H5CH2. You can write this equation. in this way. Cadmium, CH2, CC6H5. Okay. So dibenzyl cadmium is it here, and that reacts with CH3, COCl. So you can write like this. That is Cl, CH3, C double bond 4. And it requires 2 moles. So you can write another Cl, C double bond 4, CH. So it reacts with the 2 moles. So what happens here? Cadmium chloride is flat. So that the remaining will be, that is COCH. So this is CH5, CH2, and you are able to get 2 moles of what? Phenyl propamate. Okay, CH5, CH2. Okay, that is C6H5 CH2. Then you have COCH. So COCH3, but you've got 2 moles. Okay, C6H5 CH2, COCH3. And what do you call this one? This is actually propanol. Okay, and where you have got phenyl. So this can be called phenyl. This is phenyl. This is CH3, C double bond O CH3. So this is propanol and 2 phenyl. There is 1 phenyl propanol. Okay, later. Why it is 1 phenyl? Because this is the functional group and this is the first covalent on the left side. So 1 phenyl propanol. Then let us proceed with CH3, C triple bond C, CH3. So CH3, CH plus mercury in presence of mercurous ion, Hg2 plus mercuric ion, and then sulfuric acid, H2SO4. So what could be the product? Now listen. Actually, in this case, it tautomerizes. Tautomerism takes place. What is tautomerism? Tauto, T-A-U-T-O means to swing here and there. And this is acetylene, that is ethyne. This is acetylene or ethyne. Okay, and actually CH, not C. So one hydrogen is replaced by CH3. So CH3, C triple bond, CH. It means 1, 2, 3. Propine, 1 propine. Or propine. Okay. So when this propine is treated with mercuric ion, and let me discuss about this one also. Hg2 plus is called mercuric ion. That is HgCl. Similarly, Hg plus and actually this is called mercurous ion, but it is dimerizing. That is, it is available as a dimer. So it's represented as Hg2 2 plus. This is called mercurous ion. Mercurous. Or you can call it mercury 1 ion, mercury 2 ion. And the formula for this one Hg2Cl2, mercurous chloride. Now we are considering mercuric ion in the presence of sulfuric acid. Here you are able to get CH3, C, and here you are able to get OH here. The triple bond is broken and it becomes a double bond, CH2. So one hydrogen and one hydroxyl group is a kind of hydration. So the addition across the triple bond has taken place. One hydrogen, that's why it becomes CH2. One hydroxyl group, so this is OH group. One bond is broken, so double bond. But whenever you have got any hydroxyl group attached to carbon atom bearing double bond, which should be called enol. Okay, take that. Now this enol has a tendency to transfer the hydrogen to the next carbon atom. So this will swing, and this is called tautomerism. Tauto means swing. So by swinging, it is the swinging of smaller atom like hydrogen, that is only hydrogen. So it becomes CH3, C double bond O, and since it has come as a CH3, it becomes single bond CH3. It means this bond goes. So you are able to get Rc2, that is nothing but propanol. So this is one of the important method of preparation of acetate. Then this is benzene. This one is chlorine, and in the para position you have got nitro. What do you call it? Orthonitro-toluene. Ortho, not ortho. Para-nitro-toluene. Para-nitro-toluene. So that is subjected to oxidation using CrO2, chromic chloride, CrO2Cl2, then protonated water, that is H3O plus. It means H plus and H2. Here you are in what are the products? Now we have to establish. We are able to get the same nitro group. The benzene structure is not disturbed, only the CH3 is affected here. And instead of that is, you have got 3H, you have to take 2 hydrogen from here. Okay, so 2 hydrogen from here and 1 Cl, that is each Cl. Okay, so that you are able to get, actually it involves 2 moles. So this gives CH, and now you have this O, it is routed through O. So O, and then Cl, Cl2, OH, because it is hydrated. And here O, Cl, Cl2, OH. And it is on further protonation, hydrolysis. H3O plus means hydrated water, means protonated water. It means acidic hydrolysis almost. You are able to get aldehyde. So these bonds are broken here. Okay. And this results CHO group here. So it means we are able to get nitro benzoyl. So para nitro benzoyl. So the acylation, we were discussing about the acylation reaction. This kind of acylation reaction, alkylation reaction, or methylation reactions in presence of anhydrous aluminum fluoride, they are called Friedel-Crafts reaction. So since it is acetylated, it is called Friedel-Crafts acylation. Okay, this is known as Friedel-Crafts acylation. ACY, Friedel-Crafts acylation. And this chromic chloride we are used, and that reaction is a specific reaction, a named reaction called the third reaction. And what do you call this one? This is known as chromine chloride. So these are all very important features. Now you can find this question is based on the preparation of aldehydes and ketones. So when you study preparation, you have to be very careful about the specific reactions. So this is based on three power. These reaction and this question is based on preparation. So in organic chemistry, you can have the IUPAC based questions, then preparation based questions, then physical property based questions, where you will find that increasing order or decreasing order of the boiling point, etc. And you have general chemical properties based questions, and you may have application based questions. And if you've got any isomerism, you may expect some isomerism based questions. So this is a bit harass. Now let us discuss. So that is why I suggest whenever you study IUPOP, immediately go through the in-text question, example problems related to IUPOP, and immediately work out the textbook problems. You should be able to identify the type of question source. And similarly, you are supposed to identify the problems asked under preparation. So this is also in text example, textbook questions. Similarly, in text physical properties example and textbook questions. So likewise, we are talking. Now let me discuss the physical property based question. Take up question number 3. Arrange the following compounds in the increasing order of boiling point. CH3, CHO, CH3, CH2, OH, CH3, 4, CH3, CH3, CH2, CH3. Now, I will give you some tools. Based on that, you will be able to arrive at the exact answer. Let us, first of all, discuss about the factors that influence in boiling point.
Yes, the inverse of
So the boiling point, this let us always consider increase, and accordingly we can change. So the boiling point increases with the increase in the molecular mass. When there is a more interactive, that is intermolecular H bonding, there will be more boiling point. When there is more polarity, there is an increase in the boiling point. When there is more dipole-dipole interaction, there will be more boiling point. When there is a weak van der Waals force, okay, when there is van der Waals force, the boiling point actually decreases. Okay, so in this case, so in this case, so here it increases, here it increases, here it increases, here it increases, and here it decreases. Okay, so likewise you can because of the modules, four modules force. There's a weak force. So you can list out all the points and based on that you can attack. So in this case, you know very well, if there is any polarity means there should be some electronegativity. And electronegativity here, which are the electronegative atom? Oxygen is the electronegative atom. Okay. And in which compound there is no electronegative atom at all? This one.
last.
So it means no polarity, no dipole moment, no interactive H bond, and naturally this will be the lowest. So immediately you can come to that. And before that, you have to work out the molecular weight also, because I told you it is dependent on molar mass. Now, what is the molar mass of this one? Now I have given how many factors? Factor number 1, 2, 3, 4, 5 factor there. Now listen, see 2 carbon, okay, so 24. What is the hydrogen? 4. Oxygen 16. So 20, 44. Then what about this?
46.
24, 5, 6.
46.
It means 46. What about this?
46.
There is 12, 24, 6, 30, 16, 46. And then
44.
from here 45, yeah,
45.
45. Okay.
9.
And here 1, 2, 3. How much?
44.
1, 2, 3 means 36.
36. Plus 8.
3 plus 2,
44.
5 plus 3, 8. So 44. So first you have to make like this. Which is the lowest one? The lowest molecular weight will be having the lower boiling. Okay, so in that case, you have got two, and these are high. Okay, so among these are two. So now we have to select. So this is also 44. This is also 44. So in that case, what is the next parameter based on which we can decide? It has got polarity. It doesn't have polarity. So therefore this one. So CH3, CH4, CH3. Okay. Now less than. And the next one here, this is CH4 and this is CH4, CH3, CH3. Listen. So here the CH3 or CH3, right? So actually the CH3, CHO, and let us compare 44, 46. So you will have the tendency to write the CH3, CHO. But the CH3 or CH3, listen, in this case, that is, this is more polar and this is less polar. How means that is your got CHO, hydrogen bonding is also there, whereas it is less. So compared to this, this is the second one. So CH3. Ether, you know very well, ether is low boiling, quickly evaporated. Then, now we are finished with these two, and you have to take a judgment. So, in this case, you have got the hydrogen bonding in CH2OH, and therefore, this will be the last one, and this comes to the third one. So, CHO, and then CH3, CH2. So, what are the silent features of this one? Why it is having high boiling? Because of the that is molecular mass wise, it may be less than that of a CH3 or CH3. You have to justify, you have to explain like this based on this parameter. Okay. Even though it has got lower molecular weight, it has got the high boiling nature because of what? The intermolecular hydrogen. Are you will follow? So that is the reason. And what about this CH3 into this one? And here it doesn't have H, that is hydroxy group, whereas it is only an ether. Okay, and the dipole moment is also it is symmetric, so zero, right? CH3 it has got the equal good oxygen share. So CH3 methane, I mean methyl group is the electron releasing group. So on both sides equally it is releasing. So it means what dipole moment is zero, and that is why it occupies the second position. Now you can say that is the boiling point increases in this order. That is CH3, CH2, CH3, that is propane, is less boiling than CH3O, CH3. What is that? Ether. This is after all alkene. Okay, it's a gas actually, propane gas. And here is an ether. This is a liquid, fast evaporating liquid. And what about this? This is acetaldehyde, whereas this one is alcohol, that is ethanol. Okay. So likewise, you have to arrive at some judgment.